So good morning, ma'am. I'm Nirja Sukhadia from the Students Magazine Club, and this is Akash, and we are here to have a conversation on what is computational music and a brief about that. So can we start?
Yeah.
Sure. Where do we start? Directly from the
I
computation?
think
Yes.
I think you can begin by if you talk a bit about yourself and just a small gist of the field in general.
Okay. Hello, I am Kunjal Gajjar, and I'm in the field of academics since 2009. My major study area is computer science, and I usually teach in the subjects of database management systems and mobile application development, animation and multimedia. My research area majorly lies in the field of computational music, though, and in computational music also I am much interested in the field of Indian classical music
Right.
and computation in that field. That's about the brief introduction about myself. And now let's talk about computational music, what exactly computational music is. If we break these two words, musicology is something related to music and its analysis. And computation is, you can say, it's the algorithms or the calculations which are followed for the processing. So bringing these two terms together, computational music is largely, it is the field, it's an interdisciplinary field which requires the knowledge of music and computation, and if they are brought together we can build the expert systems for music analysis, and which can be further, of course, broken down into multiple subfields. So largely, if I have to explain, or we need to just summarize what computational music is, it is one of the subfield of artificial intelligence which deals with the computation and music to generate the export systems. Okay, so yeah.
So where do we use computational music? Where it is used currently, and is it very common that we interact with in our day-to-day lives?
So yes, computational music, nowadays there are lots of applications, lots of softwares that are there which use the algorithms which are analyzing the music, which are recognizing music actually. One of the major field in the computational music is music information retrieval. So all these applications that we use nowadays, like if it's a Spotify or if it's Ghana, any kind of music library, basically, it uses the concept of computational music. Okay, so just to give you the understanding of how it is used, these softwares have the huge libraries of billions of songs. Okay, now these songs, of course, they have the tagging, they have their genres which are tagged, they have artists which are tagged. But searching from these large database is a huge task. It will take a lot of time. But these applications are very quick. So there are some algorithms which are designed in such a way that from these huge libraries also we are able to extract the songs. Okay. This is when we have the text tagging which is done. But apart from this, there are softwares like Shazam, okay, which does not need any kind of text. It can actually recognize the song from the music part of it. Okay, so when we use it on the regular basis, whenever we hear any song in the background and we don't know song belongs to which artist or from which album, we usually can just record a small piece of it, and from that huge library of billions of songs, it can extract a song for us, and it can give results within seconds. Now that is possible because of the computational musicology. Okay, so these are some examples of the applications which we use in our day-to-day routine life. Apart from this, there are various research applications also which you can find, which are dealing more on the technical part of it and not just the music information retrieval part. Yeah.
Okay, so you talked about it being a subset of AI. So do these algorithms, do they sort of simplify the processing of music and sort of fine-tuning the final product, if I had to put it that way?
simplify, we can say that they are more of the aid to the composer.
Right.
Okay, so so there are multiple such softwares which work like the tools which helps the composer when they are generating the music. When it comes to only machines generating the music, that can, of course, it can be done, but the outcome,
Yeah.
how good the outcome is, that ultimately has to be decided by the humans, because machines do not have that understanding that how beautiful this song is, or how aesthetically how this song sounds like. Okay, so for that, of course, we'll need human interactions. But these can be generated, and when the composition is happening, at that time they can work as an assistant to the composer, which can help in generating various, like the variations, or they can give suggestions to the composers that these tunes can be used along with these notes. When I say tunes, I mean that notes can be combined in these ways, and multiple different kinds of outputs can be generated. And then, of course, the composer can decide what to select and what not to. Yeah. So ultimately, it helps in enhancing the
As an
outcome.
aid. As an aid, yeah.
Yes.
So you said you are interested in Indian classical and computation music. So how are these two related? Because computation music is something that came up recently. Is it?
Okay, so when we say recently, yeah, of course, recently, reason is that this term was first coined in the years of 1960s.
Okay.
This was when in the Bell Labs, in IBM laboratories, initial music generation was being done with the help of the computers. Then from 1960s to 70s, there was a era when the music generation with the help of the computers, it can be done, or it can be analyzed, or some feature extractions can be done. These kind of studies were done. 1980s was the time when the music information retrieval came into the picture, and then there was a lot of study. So relatively, if you compare it with the other computation areas, of course it is new. Initial phases, we can find that there are a lot of research papers which are based on the Western music. So Western classical music and Indian classical music, they have some similarities, but there are a lot of differences also. I can point out a few, like for instance, Western music mostly relies on the harmonics. So they have these chords, multiple notes can be played together. Okay, whereas Indian classical music is more of the melody. So there is like a individual tone which is played, and that transition from one note to another is the important part. Okay, another major difference is the raga structure. Indian classical music follows the raga structure. There are some rules that when you are ascending or descending some from some notes, this is the way you are able to transit. Western classical music does not follow any such structure. There are some basic rules, or there are some dominant notes which a composer has to follow, but otherwise there is no such structure. But when it comes to Indian classical music, based on the mood, based on what type of rag you are following, you have to follow the rules of during the composition. Third major difference is Indian classical music also has some complex beat cycles. So there is tal. Along with the rag, there is a concept of tal. That doesn't mean that Western music does not follow any rhythm. There is a rhythm, but there are no strict rules to follow those rhythms, or they'll not define the structure of that composition. Whereas in Indian classical music, rhythm is again a very, very major component. You have to follow those complex beat cycles, and they'll decide the correctness of the song also. Okay, so so that is again one of the main component. Apart from that, there are concepts like Indian classical music believes in improvisation during the real-time rendition. So there are notes, or there is a song which is composed, but you will usually see that when the artist recites that composition on stage or in real time, they'll do a lot of variations. Okay, so it's not that the same notations have to be followed. There'll be a lot of variations, improvisation, and that is the beauty of Indian classical music. Whereas in Western music, when once there is a predefined notation or a composition is there, artists would try to stick to that. There won't be a lot of improvisation that is done at the real-time renditions. And last is the learning pedagogy. Indian classical music does not, it's more on the that guru shishya pedagogy thing, right? Western music is that if you have those notations, somebody can play it on the piano or on guitar and they can learn it, and that is how they learn the music part. Indian classical music does not work that way. They have this teacher and student chemistry, and usually a student would learn by imitation of the guru or by following the direct instructions from the guru, and that is how it works. And that's why there is a lot of creativity which happens even when they follow guru or when they are learning from them. They can improvise their own compositions also. They can do a lot of creative stuff in it, and that's why when we talk about computational music from Indian classical perspective, it becomes more complicated because there are no fixed set of notes that are followed, and there are a lot of variations which happen. So that's how they are different. And so when we go by the history, there is a lot of work which is done in the Western music. Indian classical music is relatively untouched, we can say. For this reason, because there is a lot of complexity. So first one has to understand the raga structure. First one has to see that how this can be you can say used in the algorithm. Okay, and then following these rules, how we can go ahead by the composition or music generation.
So where do you see the future of computational music? How?
So computation music, largely, if I have to see, it can be divided into three domains. One is, of course, the music information retrieval, the examples that we talked about. Another major area in computation music is music composition or generation. We don't find very sophisticated tools which are yet available where we can just rely on the machines for the composition part. So as I said, they are more of an assistant to the composer. They can help in or they can help in generation of the music. They can make their task very easy because now a composer does not need entire orchestra to compose something. Okay, there are a lot of synthesizers and sequencers softwares which are available, which helps them to generate the music part of it. A lot of work can be actually done in this field because now as we see that artificial intelligence and machine learning, they are evolving, and as they are evolving, there are a lot of new techniques that are coming up. Based on those techniques, I think we can make these kind of softwares which are more on the assistant side. They can actually become more powerful, and they can help composers for generating new kind of music also. Third area of computation music is music recognition. Now, music recognition is actually what it deals with the feature extraction part. When we say feature, it means if a song is playing, based on the frequency of the song or frequency of the notes can be identified. You can extract the pitch, you can extract the information of rhythm, you can extract the basically using these information you can classify it into different genres. You can classify it into different kinds of categories of songs also. So all this comes under the recognition part. Again, when we talk about Indian music part, this field is also relatively untouched. There are a lot of research papers where you will find that based on some song or some instrument is playing some song, and you are trying to identify the notes out of it, and based on that note we try to identify which rag is being played. Okay, when we talk about the accuracy of these algorithms, there are some algorithms which are giving us like 90% of accuracy also, but they are for relatively simple song. When the complexity of the rendition increases, when there are a lot of variations which happen and which are in a very, very small duration of time. Okay. Just to give you an example, when I have to identify the note, I need some time, right? Some time to decide that this is the note which is getting played. So let's say for every 25 milliseconds, I'll extract the frequency, and based on that, I'll identify which are the notes. But with the Indian classical music, there are a lot of transitions which happen even within these milliseconds. So to then identify the notes is a very, very complex task. And then based on that to identify the raga is again a very complex task. So there is a lot of research which is already being done in this field of music recognition. And when we say future trend based on the AI, based on machine learning, we can definitely these algorithms can be improvised. There are a lot of models which are being used for music generation. Like there are Markov chain models which are used for music generation part. Okay, and as I said, that these evolutionary algorithms, when they'll keep improving day by day, we'll get better output also. Lastly, I feel that along with these two, there is one more aspect of virtual reality also. When computational music, if it can be clubbed with virtual reality or augmented or mixed reality, all these terms actually they can be connected or used interchangeably. When when the virtual reality and computational music, when they'll come together, we can actually get some kind of a immersive environment for the learners also. So what used to happen in the earlier period, that there'll be a guru and shishya, and for whole day they'll be riyasing. Now that's not possible nowadays, right? Usually we'll see that there's a 1 hour of session with the guru, and then rest of the time a student has to practice on their own. Now imagine that if these technology can come together and provide such kind of a immersive environment where a student has that virtual instructor who helps the student to learn also. Okay, and the student feels that there is somebody who is guiding, who is giving them the instruction, helping the novice musicians to learn the music. So I feel that can be like one of the future trend. When these technologies will come together, we'll be able to see that kind of a immersive environment. And I don't see that it's not possible or anything. They are there in the market. We have a lot of immersive such softwares which are available, right? To a certain extent, it has happened. Like many students use softwares like Star Maker. That's a real time. So it's like a karaoke app. It has a music which is playing in the background, and you can actually sing. These two get combined, and you see the output. That is happening in the real time. This is like one step to the immersive or an interactive kind of a system. Taking this forward with virtual reality will give us a great environment for the learners. Yeah.
Do you have anything that you would like to add? Anything that we might not have
Anything
covered? Any aspect?
No, I think we have largely covered all the future trends also, and as I said, that majorly these three areas of the computational music, that is music information retrieval, recognition, and generation. Yeah. So yeah, largely we have covered everything.
Yeah.
Right.
We don't. That's
Yeah,
it.
good.
Yes.
Is the content enough for you?
Yeah,
That is the
Good conversation.
Yeah.
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 Okay.
Thank you, ma'am.
Thank you so much.
That was
Yeah.
great. I mean, I also was able to revise my thesis.
So, what is it? What is the topic of your thesis?
My thesis is on building an expert system which will work for the evaluation of the song rendered in the Indian classical music, mostly on the Hindustani classical music side. Yeah. So that's my thesis.
Interesting.
Yeah.
Okay.
Right.
Yeah.
Yeah.
Thank
Okay.
you so much.
Thanks. Yeah.
About 18 to 19 minutes.
Okay.
Fair
Great.
enough.
Good.